Welcome to EDU World Space.
Okay, so here we're asked to write the electron configuration of various ions and determine which ones have noble gas configurations. So let's start with the first one. And we'll need to look at the periodic table. Okay, so here we're asked to write the electron configuration. So this is ruthenium, and it has 44 protons. It's a transition metal, so let's see what it would be. So this would be, okay, so here we're asked to write the electron configuration. So we'll find it on the table, and we'll definitely have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then we jump to 3d10. Remember, we have to jump to the 3d orbitals after the 4s2s. We'll fill the 4p6, and here's where we have to be careful because this is an ion, and so we've lost 3 electrons, so we need to move back 3 from where the ruthenium is. So we have to be really careful. So 5s, we should be able to fill both of them, 2. And then, instead of having what would be 4d 1, 2, 3, 4, 5, 6, if it wasn't an ion, we'll have 4d3. Okay, and that's not going to be a noble gas configuration, so we'll move on to the next one. So the next one we'll do is As. Okay, so let's find that on the periodic table. Okay, so here we're asked to write the electron configuration. So arsenic with atomic number 33. And it has a -3 charge, which means it's gained 3 electrons. So let's get started, and then we'll deal with the additional 3 electrons when we get to it. So this is definitely a 1s2, 2s2, 2p6, 3s2, 3p6. We'll fill the 4s2, the 3d10 orbital, all 10 of those. And then if we were at arsenic and we stayed there, we would do 4p3, but we have to add 3 electrons, so it's actually going to be 4p6. And because we did this, this has a noble gas configuration. It has the noble gas configuration of krypton. Okay. We will move on to C. Okay, so here we're asked to write the electron configuration. Okay, so next we have yttrium with an ion that is a +3 charge, so it has lost 3 electrons. So let's go ahead and get started. We'll find it on the periodic table, atomic number of 39. So we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. We'll fill the 3d orbital, 3d10, 4p6. Okay, and if we were going to fill this out for the uncharged version, we would do 5s2, 4d1. But we've actually lost 3 electrons, so we're going to stop here, because 5s2, that's 2, and the 1 from the 4d orbital. So this is also a noble gas configuration. And it's actually the same one as above. It's going to be krypton again. Okay, we'll move on to our next one. Okay, so here we're asked to write the electron configuration, which is palladium, atomic number 46, and it has a +2 charge. So let's get started. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d all full, 3d10, 4p6. And now, let's see, so 4p6, and then we would normally do 5s2 followed by 4d 1, 2, 3, 4, 5, 6, 7, 8, but it's pd2 plus, so we've actually lost 2 electrons. So it should be, instead of 4d8, it should be 4d6. Okay? So that's not going to be noble gas configuration. Next, we're going to do lead. And so let's find that on the periodic table. Okay, so here we're asked to write the electron configuration. Atomic number 82. So, and there's a +2 charge, so it lost 2 electrons. So, let's start from the top. 1s2, 2s2, 2p6, 3s2, 3s2, 3p6, 4s2, we'll fill the 3d all the way, 310, 4p6, we'll fill the 5s2, 4d10, that's full, 5p6, we'll drop down to fill the 6s2 orbitals, and here's the first time we have to make sure we fill our 4f orbitals. 4f14, okay? And now, if we were doing this for the uncharged version, we would write 5d10 and 6p2, but remember we lost 2 electrons, so we're actually going to stop here. And so this is not going to be a noble gas configuration. Okay? And the final ion that we're going to do. Okay, so here we're asked to write the electron configuration is gold with a +3 charge. This is going to be very similar to what we just wrote out for lead, but we'll just change some things when we get to the end here. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 5s2, 4d10, 5p6, okay? Again, we'll do our 6s2 orbitals. We'll fill our 4f orbitals, 4f14, okay? And normally, if we were doing this, if it was a gold, we would go to 5d9, but we've actually lost 3 electrons. So instead of 5d9, we'll go to 5d6. And that's not a noble gas configuration.